Hey guys, welcome to Michelle's STEM Journey. I am Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2013, 10A, Problem 13, and it deals with casework. I hope you all enjoyed this video, and let's get started. The problem states how many three-digit numbers are not divisible by 5, have digits that sum to less than 20, and have the first digit equal to the third digit. Okay, to start this problem off, I am just going to be representing the three-digit number, and I'm just going to use x, y, and z. And so the numerical value for the three-digit number would actually be represented as 100x plus 10y plus z, just to throw it out there. And because the question says that the first digit has to equal to the third digit, that means that we can substitute z for x. So it would actually just be x, y, x. And then because the question also says that the digits have to sum to less than 20, that means that 2x plus y has to be less than 20. Not equal to, it's just less than. And then finally it says that it is not divisible by 5, so that means that x cannot equal to 0 or 5. So we have this all written out, and now all we have to do is just to see the possibilities. So to work this problem faster, we can actually group up the solution. So I'm just going to number it. Number 1, when x is 1, 2, 3, or 4, that means that y can be any number in the range of 0 to 9. And this is because if you plug in 4 for x into this equation right here, 4 times 2 is 8, plus y has to be less than 20. So that means that y has to be less than 12. But y can only be in the range of 0 to 9 because that is the furthest that the numbers will go, 0 to 9 for single digits. And so that means that y can be any number in the range of 0 to 9, and it will not go over the limit of 20. And because we tried that for the number 4, then that means that 1, 2, 3 will obviously work. And so here we have 4 choices for x, and then we have 10 choices for y. And so we can just multiply this to get 40. And so 40 represents the total number of combinations for when x is equal to 1, 2, 3, and 4. And then in the second case, we are just going to have to work it out digit by digit. So when x is equal to 6, because note that x cannot be 5, then when x is 6, y can be in the range of 0 to 7. And this is because you can just plug it in. 6 times 2 is 12, and so that means that y must be less than 8 for it to satisfy this inequality, because as I said, it cannot be equal to 20. So that means that the largest that y can go is 7. And so we have 1 choice for x, and then we have 8 choices for y. So that will yield to 8 possible combinations. And then when x is 7, y can be in the range of 0 to 5. And as I said, you can just plug it in. 7 times 2 is 14. Then y can be less than 6. And so that means that the range would be 0 to 5 because it cannot include 6. And so we have 1 choice for x, and then we have 6 for y. And so it would give us 6 total combinations for when x is equal to 7 and y can be any number in the range of 0 to 5. And then so we can just do the same thing for when x is 8 and for when x is 9. For when x is 8, y can be in the range of 0 to 3. And so that would give us 4 choices for y and 1 choice for x. And so it would be 4 choices. And then for when x equals 9, y can be in the range of 0 to 1. So that's 2 choices for y and then 1 choice for x. and this would give us 2 total combinations for when x is 9. And so here we have written out all of the total combinations. So 48, 6, 4, and 2, and now all we have to do is add it up. So here we see that we have 60 total combinations. So that means that we have 60 total number of 3-digit numbers that satisfies all of these requirements. So therefore, the answer is B, 60.